morning. I'm Giuseppe Lopappa from Palermo University and visiting professor at the North Kazakhstan State University. So today I will give to you a very short presentation about the soil, and in particular the soil formation and the soil texture, which is the most important property of the soil. So I'm a pedologist, so I'm a soil scientist, and then this lecture is for students who want to attend and who want to understand about soil. So what is soil? Soil is a natural body which is formed on the land surface, and the formation of the soil can take a very long time, sometimes even centuries or thousands of years. So the soil formation is regulated by 5 main factors that influence how fast and how soil forms, and of course regulating all the processes of the soil formation that will be expressed by soil characteristics and soil properties. So these factors, so we say, are 5 factors. We have the climate. Second is the organism. Third is the relief or topography, the land morphology, the surface morphology. And we have the parent material, of course, and we have the time. So these have been stated in a sort of equation of soil formation that they say that soil is formed by these 5 factors. The name of this equation is the CLORP equation, because using the abbreviation of the 5 factors: climate, organism, relief, parent material, and time. So we have a quick look on each factor to understand how interact with the other factors. All the factors that they interact all together to form soil. So the first factor is the climate. So climatic factors such as precipitation and temperature, these are the main factors of the climate that affect the soil formation and affect how fast soil forms. So these factors cause the weathering. So weathering of what? Weathering of course, the parent material. So the rock lying on the bedrock lying below the soil. So weathering, of course, is important soil formation. So, for example, increasing precipitation and as much as warmer is the temperature, the weathering is faster. And of course, this led to a faster soil formation. So precipitation, rainfall, and temperature are the main factor in climate for soil formation. So second factor, very important, the organisms. So living organisms, for example, they are decomposer, especially they act on the soil or on the organic matter which is falling down or you can find on the soil surface. So they are breaking down, they are degrading this kind, transforming this kind of organic matter, forming humus part, and part is already mineralized. And organic matter that we can find in different forms in the soil, from fresh one to the most decomposed and until to the humus that can lay in the soil, can stay in the soil even for thousands of years. It's a very important component of the soil which differentiated the soil from the parent material. So that's because just to understand how much important is the action of the organisms. So, of course, the types and the amount of this decomposer of the organic matter in the soil can affect how fast organic matter forms, how much humus can form in the soil, how much long this organic matter can stay in the soil. One particular organism, of course, that is also a factor of soil formation and nowadays is much more fast-acting factor are the humans. This is another factor, but we include humans inside the organisms. The third factor is the topography, or land morphology, or relief. Especially, there are two factors affecting the soil formation, which are elevation and slope gradients. That they usually characterize, the shape of a land, the morphology of a land. Topography affects, of course, how fast soil forms, and in particular is affecting indirectly the soil formation because it's affecting the water flow and water infiltration in the slopes, and also the solar radiation that could reach the soil surface. So, of course, this is affecting, for example, usually we have different soils. If a soil is in a steepest slope, or soil is in a plain, or soil is in a flat morphology. And also considering the position in the landscape, in the land surface morphology. So also this indeed condition a sort of type of soils. So it's one of the most important factors in soil formation. So affecting the soil variability and in the landscape. So the fourth, but not less important factor, of course, is the parent material. So parent material is mineral, especially minerals, could be solid rock and minerals, and unconsolidated also deposits that will transform over time into the soil. So over time, parent material breaks down to form soil. And of course, some rocks or minerals, they are much more easy to be weathering by the climate, by the organism, by the chemical and physical processes regulating the soil formation. Of course, depending the parent material, we have parent material very hard rock that could be weathered in very long times, but we have, for example, unconsolidated material that could be transformed into soil quite faster. Okay. Time, of course, is the other important factor because everything is going over time. So, in order for forming soil, first we start from the parent material. Parent material, we say that is solid rock or and minerals. Usually, the parent material, when it's exposed to a climatic factor and to the action of organisms, is weathered in something different that we call soil. And then organisms in particular, they can also add organic matter to form soil. So these are natural processes, of course, and these, for example, this picture is showing how the first initial formation of the soil, which is just the physical weathering, of the rock, that could be by the water and temperature, of course. So the first action of transforming parent material is, of course, to break down minerals and rock in much more smaller particles. Of course, other factors influencing the degradation, the alteration, the weathering of the rock are wind, of course, and also water, but also plants, especially with the roots or by chemical interaction with the rock. So you can see a soil profile, for example. You can see that is completely different from the bedrock, and especially in the uppermost part of the soil profile, close to the soil surface, we can see there is also we can find finer particles forming the soil, and the minerals are being completely transformed in different minerals by weathering, by physical weathering, but also by chemical transformation of the minerals. So, of course, plants live in the, usually the plant roots and the organisms, they live mostly in the upper part of the soil profile. And you can see, for example, a more dark color, brown color, because is the effect of the organic matter which is added and in the uppermost part of the soil profile. So organisms, of course, decompose into organic matter, which is incorporated with the minerals that is forming soils. And this process is, over time, transforms the minerals in the soil. So there is also an interaction between the organic matter and the mineral particles of the soil. So that is more or less a very quick way how soil form, a very rough talk about how soil form. So now we talk about the soil texture. Soil texture is one of the many characteristics of the soil. There are many characteristics of the soil. There are physical characteristics, there are mineralogical characteristics, there are chemical characteristics of soil. There are also biological, microbiological characteristics of the soil. So among the physical characteristics, we have texture, density, color, consistency, porosity. Also, we have other kind of physical characteristics like hydrological characteristics of soils. But texture is the most important. So, why is most important? It's roughly is a sort of measure, a sort of characteristic that, is telling us how is made soil. And texture, of course, depends on the size of the particles forming soils. So texture is essentially is giving to us the information how the particles, the mineral particles of the soils are distributed in some classes that we define. Because it's very important we talk about soil texture, because in some way it's affecting all the other properties of the soil, both in terms of physical properties or chemical properties. For example, soil structure or soil density or consistency, even porosity, they are affected by soil texture. Chemical properties, for example, like the cation exchange capacity or the pH or other properties, they are, of course, influenced by the texture of the soil. So just to look how we have how the particles of the soil we can determine and we can assess different classes, we can understand the behavior of the soil, especially when we talk about hydrology of the soil. So when we talk about soil texture, we are considering, usually we consider three main classes. We consider sands, we are the more coarse fraction of the soil particles, including the more coarse fraction. We have silt, which is an intermediate class, and then we have clay, which is the finest particles, which are the finest particles of the soil. Sand, of course, is made by, we say that large or coarse particles, and we define sands in the soil. How you can see in the picture, we can also watch the sand granules particles with our eyes. The class, we define the class sand as all the particles having size expressed in mean diameters of the particles from 2 millimeters up to 0.05 millimeters. Okay, when we have, of course, we can also feel with our fingers, with our hands, the sands, because it feel these large particles. They feel gritty or rough when we just touch the soil particles. Of course, it's very important to have a good fraction of sand in the soil, because it allows water and air to pass through the soil easily. But unfortunately, these particles, since they are very big particles, they are coarse particles and mainly formed by inert material like quartz, they cannot hold nutrients or water as well. Silt, we say, is an intermediate part of the soil particles, mineral soil particles. Is made by medium size of particles. We define silts, all the particles having a mean diameter from 0.05 millimeters up to 0.002 millimeters. That means 2 microns. Of course, it's made by smaller particles and is not as raw as sand. And when it's dry, our feeling when we touch this silt is like a smooth powder. And when it's wet, we feel like it will be, it feels like slippery. I mean, like it could be like soap, or we are touching soap. Of course, because these particles are smaller, they are more active than sand. Allows some drainage and air to pass through, but holds onto nutrients. And of course, depending how much of the silt we have in the soil, it could affect the soil properties. Clay, we say, is the most fine particles, mineral particles forming the soil. We define the clay class as all the particles of the mineral particles of the soil having mean diameters less than 2 microns or 0.002 millimeters. So when it's dry, clay feels very smooth and hard. When it's wet, is usually sticky and plastic. Because the particles are very fine, it holds onto water and nutrient very well. So these are the most active particles of the soil, holding nutrients and exchanging nutrients. They are on the base of the cation exchange capacity of the soil, which is a very important chemical property of the soil. And when it's wet, clay gets heavy from the water and becomes very hard when it's dry. So when we have very clay soils, that is a problem because we have no good drainage of the soil. But when it's dry, probably is forming a good structure, is forming a good structure. So the water can pass very quickly through these soils. But when is wet, that could be a big problem for water movement inside the soil. So on the base of the clay and content and silt content and sand content, I mean the texture, we usually define and classify some types of soils. Of course, considering these most three fractions of the soil, we define sandy soils, we define clayey soils, we define silty soil. That means that one fraction, when we determine when we assess the particle size analysis, so we do this in the lab with a physical analysis, a physical determination, usually by sedimentation. We determine how much sand, how much clay, how much silt we have in a soil. So the most important classes, when one class of these is dominant in our soil, that means we have sandy soil, clay soil, or silty soil. But we have also a main class, which is loamy soil. Well, sandy soils, of course, is the mostly but not entirely made of sand. Usually these sandy soils, we need to have at least the 85% of sand to be defined, even sometimes 90 or more than 90% of sandy to be defined sandy soils. Usually we have also in clayey soils, we can have a content of sandy soils that could be around 40 or 30%. It's the most dominant, usually in terms of percent, the most dominant particles in the soils, because we determine the particle size analysis by weight. And then that means that these big particles are, of course, they weigh more than clay or silt. So we need very few particles to have in the soil to have, for example, a 20% of sand in our soil. Sandy soils, they are really sometimes we can find in less deposit, we can find close to the coast. In sandy beach, for example, they are made by sandy soil. So they are quite problematic because they cannot hold, the water holding capacity is very low. On the counterpart, we have a lot of oxygen, so this leads to oxidative process of the organic matter, so mineralization of organic matter, but especially is a problematic soil, the sandy one, because we cannot, so it's not holding a lot of water over time. And it drains quickly when we irrigate, for example, this kind of soils. Clay soils, on the other side, which are rich in clay, they are made by clay, but not entirely. We will see that we need, for example, just the 40% or 35 or even 30% of clay to define a soil clayey. Of course, is made by the smallest particles. We have a lot of smaller particles. And sometimes is still problematic because when the structure is massive, this avoids the water passing through the soil. And of course, on the other counterpart, it's holding a lot of nutrients for the soil. Clay soils we can find everywhere. They are typical of many environments. Silty soil, they are not so common. We can find sometimes very close to the rivers or in some particular environments. At the end, we have the loamy soils. That what means loamy soils? Loamy soils is made of almost equal parts of sand, clay, and silt. They are well balanced. Soils. So we have not, of course, the 33% of sand, of clay, and silt. Our soil having the 33% we said is clayey. But I mean, we have such proportion of clay, silt, and sand that the properties of the single classes is not dominating the other classes. That means that the results, the behavior of these soils is well balanced, is harmonic. So this kind of soils, what we define loamy soils, are the ideal soil types in agriculture especially. because we have a good balance of the three soil textures. And if we consider that we have organic matter, so this is improving, of course, our physical and chemical characteristics. So the water holding capacity is well balanced. We have water that we can be held in the soil. We have a good ratio of nutrients. It drains the water very well. So we have a right proportion of air and water in the soil. As root plants, they need both oxygen and they need also water for the nutrition and for the respiration. So they are well-balanced soil. They are very good and fertile, physically fertile soils that we can have in our planet. Of course, we use these soils especially for farming and for agricultural uses, because we can grow many crops. We can use for many agricultural purposes. Of course, there are also texture classes. This is, for example, the texture triangle we use. After we determine the percent, we make the particle size analysis, we determine the percent of the three classes of the particles. We distribute all the mineral particles in three classes by physical analysis in the lab. And then we go to determine, with this triangle, we go to determine which is the class, texture class in which our soil belongs. Of course, we have clay soil, we have silt soil, we have sand soil. Sand soil, for example, you can see are made by more than 90% of, we need to have more than 90% of sand to be defined as sandy soil. More than 90% or 80% of silt to define silty soil. When we talk about clay soils, you can see we need to have just the 40% of clay. So when we have more than 40% of clay, the most of our soil, we can define clayly soils. Of course, we have also intermediate texture classes. So for example, clayly loam or silty clayly loam or silty clay, silty loam. They are intermediate classes, and we can use this triangle to classify, to find the texture class of our soil or of our horizon. And you can see which are the percentage that we need to define our loam class or loamy soils. Okay, thank you very much.